Okay, dear students, let us see what is there in this question. Properties of waves are polarization, diffraction, refraction. Which of these properties apply to the sound waves? Well, my dear students, sound waves is an example of longitudinal waves. Fine. Longitudinal waves have this property that the particles are vibrating along the direction of the wave only. They are not transverse. So what happens there is polarization is the event, is the phenomena that is not shown by sound waves. Polarization is one of those phenomena which are basically used to prove that transverse wave exists and so wave is actually a transverse wave. We use this as a test of what kind of a wave is it. If the wave passes through it, it is called longitudinal wave, and if the wave is not able to pass through it, or the intensity reduces, or you have seen like if we are using two polaroids and we are having the axis 90-degree, so obviously the intensity outside will be zero. If it is not coming out to be zero, it is longitudinal wave. If it is zero, it is a transverse wave. So the first thing is that polarization is not shown by sound wave. But what about diffraction? Absolutely correct. Diffraction is maximum in sound wave. What is diffraction? Like diffraction is bending around the corners. Obviously, like let us say if there is this person standing here and there is another person standing here, these are two walls around the corner. Now he's speaking something. Obviously, this person is able to hear him. So you see, these waves are able to bend themselves by 90 degrees. Now, this bending is really immense in the case of sound. So, diffraction is maximum in the case of sound. So, diffraction is present there, and refraction is also present in the sound waves. How can we say that? What is the practical example of this thing? Where the refraction of the sound is taking place, or the longitudinal wave is taking place, or the pressure wave is taking place. You know what? Earthquakes, or you can say seismic waves. So these seismic waves created in the earthquake, they are kind of pressure waves. They can be compared with the sound wave, and they always get refracted with the medium. For example, in the earth crust, the density is lesser. As we move towards the core of the earth, it becomes metallic and the density becomes very high. So the sounds they get reflected back into the towards the earth crust back again. So there is a phenomena associated with refraction of sound, and that is earthquake. So you can just go to Google and you can search for videos, you can search for data regarding that, and if you are curious about it. Okay, so our answer here will be these properties which apply to sound wave is 2 and 3 only. So the answer will be C. So my dear students, let us verify it from the mark scheme, and yes, the answer is indeed C. So this is the explanation here. Please, this is a humble request, subscribe to the YouTube channel. All the best.